We've got lots of these type A dominoes and lots of the type B dominoes, although they can be rotated 180 degrees to look different. Tom wants to select 3 dominoes, place them next to each other to create a 2 by 3 rectangle. The dominoes remain vertical as shown, and he wants both top and bottom rows of his rectangle to contain at least 1 square of each color. How many sequences can Tom make which contain exactly 1 type A domino? So let's say the first one is a type A domino, shade it in. Now, if the second one was a type B with the bottom shaded, you couldn't put another one in like that because of the fact that he wants both top and bottom to have at least 1 square of each color. So he's going to have to use the other version of type B for the top one, which means for part A1, going to have to use all 3 types. I'm just going to justify that, write a few words down. I'm not going to do that here, but I've explained it verbally. So then he's using all 3 types. For the first domino, there's going to be 3 options. And then for the second one, there's going to be 2 options. We multiply these two together because, for example, we could have this one with this one, or we could have this one with this one. But then there's another 3 ways I could have the one on the left. So I could have that going with either of the other two, and then that one going with either the other two. That's why we do 3 times 2, because every single option on the far left has 2 options for the one in the middle. And then for the third one, there's only one option now. We just times by 1, which means our answer to A part 1 is 6. We're then asked how many sequences of 3 dominoes he can make in total. So we've looked at the situation where there's one type A domino. And so for A part 2, okay, we just need to talk about this a little bit. So we can't possibly have 2 type A dominoes. Because if you did, there's no way that you can then have a blank square here and here. So not possible. We do need to state that. And for the similar reasons, we can't have 3 type A dominoes. So therefore, we're looking for 0 type A dominoes. So let's take a look at this. We could shade the bottom 2 here, but then we'd have to shade the top one. That'd be one possibility. But be careful, we can't just say, right, there's 2 options over here, and then there's 2 options here, because it will depend what we pick here as to what we can pick here. So it's not going to be, say, 2 times 2 times 2. It's not going to be 2 times 2 times 1 even. We need a slightly different way to actually count them. And what I'm going to do is say, right, I definitely have to put in one of these. And there's actually going to be 3 places I can put it, either on the left, on the middle, in the middle, or on the right. So let's look at the scenario that I then also place 2 at the top. Well, actually, once I've placed my original one, the others are going to just fall into place. So I'm going to get 3 options. But it must be that I also get that same number of options if I have the 2 along the bottom, because I can imagine placing one that's shaded at the top in 3 different places, and then the other 2 would fall into place there as well. Actually, it turns out there's another 6 possibilities. A little bit harder to count that one. We just have to be able to justify it. I mean, at the end of the day, you could just like list them all, to be fair. But I've tried to use counting arguments because that's more, that's going to help us in the long run with these sorts of questions. So we've got 6 possibilities when there's 1 type A. We've got no possibilities when there's 2 or 3 type A's. We've got 6 possibilities when there's 0 type A's. So in total, there's going to be 12 sequences of 3 dominoes that we can make. Now for the final part, each of the white squares on type B dominoes has a whole number between 1 and 6 written on it. For example, 3 and 1. The grey squares have no number on them. So nothing on the type A's and nothing on the grey squares of the type B. And there's several copies of each numbered type B domino. We're not going to run out. Numbers don't change when we rotate them 180 degrees, so a 6 doesn't become a 9. And then Tom wants to arrange and select everything as just as before. So we need one of the top row to be coloured grey and one coloured white at least. And the same with the bottom row. But now we also wants the numbers on the top row to add to add to 6 and the numbers on the bottom row to add to 6. And how many different ways can we do this? So remember, there's no ways we can do this with 2 type A's or 3 type A's. Let's take a look at 1 type A. So we'll get this kind of set up. This one is shaded top and bottom. This one's shaded top, this one's bottom. Remember, there's 6 ways that I can then kind of configure this. But the numbers here to add up to 6 must be 6. So actually there's 6 possibilities in total from when there's 1 type A. And we'll just circle that and keep it running total. That just leaves us with 0 type A's. So I'll just shade these top 2 and the bottom one. But remember, there's 6 different ways we can arrange this. I'm going to have a 6 with the 1 by itself to add to 6, but then I could go with a 1 and a 5, or I could go with a 2 and a 4, or even a 3 and a 3. So it's just how many different arrangements we're then going to have within this. So I've got 6 different ways I can arrange the tiles, but within this arrangement, I could also swap the 1 and the 5 around, meaning that it's actually going to be 6 times 2, or 12. Let me just say that again. Remember, from above, we found out there were 6 configurations, either 2 shaded at the top. Look, I either put this one here, forget the numbers for a minute, the 1 shaded at the bottom, there's 3 different places I can put it, but I can also swap it round, so just 1 is shaded at the top, and there were 3 different ways I could put it, so 6 possibilities. But now I'm starting to number, and for every single one that I have, I can just swap the 1 and the 5 round to make another possible set. For example, I have this as one of my 6, but now I've labeled it 1, 5, and 6, but I could instead label it 5, 1, and 6, and that would be different because I've still got the same shaded kind of areas, but different numbers on them. And it's going to be exactly the same for this one, 6 times 2 again. Again, I can rearrange the shaded parts in 6 different ways, but then with the numbers, I can swap the 2 and the 4 around with each arrangement to give me 12 again. That just leaves us with the last one. See, this time if I swap the 3 and the 3 around, it will stay the same. So actually, there's just 6 possibilities here. So you just have to explain that in your Olympiad because we are being judged on our writing here. Full written solutions. Okay, I've just kind of again explained it out loud, but please make sure that you're just showing enough understanding to justify all the marks. So in how many different ways can we do it? Well, we've actually got we've got 24 plus another 12. There's going to be 36 different ways that Tom can arrange these tiles. Nice one.